Hello, Honors Algebra 2. It is Tuesday, May 5th, and we're continuing on in our Chapter 15 with Section 15.9. We're going to just talk about plain old probability today. And I noticed on the comment on the wall, Andrew said, oh, this chapter is easier. I agree. It's definitely easier than trig, but today is going to be a little bit trickier, just a little bit trickier. We're going to have a little bit more complicated probability, so hold on here. Now, probability, if you'll remember from middle school days, is a number between 0 and 1. Probability is 0 if it's impossible for it to happen. Probability is 1 if it's certain, and it can be any fraction, really decimal or percent, in between. We usually give our answer as a fraction in this section. Okay, now what is probability? Well, you want a desired event. Okay, you want something special to happen, like rolling a 5, divided by all the possible outcomes. So all the possible outcomes for rolling a die would be 1 through 6, okay? So my desired event that I want would be rolling a 5. So that would simply be 1/6. Okay, now what if I roll a die and I want my probability of getting an answer, theoretically, less than 5? Well, I know my total number of outcomes is 6 possible outcomes, and how many of those would be the event less than 5? 1, 2, 3, or 4. So I have 4 out of 6 is my probability, which would reduce to 2/3. No big deal. Now, rolling a die again, what's the probability that my answer is between 2 and 6? Well, if something is between 2 and 6, it does not include 2 and 6. So this event would not include 2 and not include 6. So what numbers does that include? It includes number 3, 4, and 5. And so my probability here, I'll put it underneath, my probability there are 3 numbers out of 6. I have a 1/2 would be my probability of being able to get numbers between 2 and 6. So it's equally likely. Okay, let's go to rolling a pair of dice. This is where it gets a little bit trickier. I want the sum of a pair of dice rolled, okay, to be, I'm rolling my dice, okay, less than 5. All right, now, when we talk about a pair of dice, I don't know if you remember this. We had this in 7th grade and in 8th grade. Ashby, you may not have had it, but it's a chart of what are my possible sums when I roll one die and another die. So the numbers inside the grid are the sums that I can get. I could roll a 1 and a 1 and get a 2. I could roll a 6 and a 6 and get a 12. And so I really have a grid of 36 possible sums. And so when I talk about rolling a pair of dice, then 36 is always the total number of sums that I can get. I want to get a sum less than 5, so I'm going to look here. There's 3 ways to get a 4, 2 ways to get a 3, 1 way to get a 2. So let's add those up. 1, 2, 3, 4, 5, 6. So there are 6 out of 36 ways for me to get a sum of 2, 3, or 4. Okay, so can you see that? I'm sorry, it's in the glare a little bit. I especially want Ashby to see that. Okay, well, it's in the glare of the screen. Oh, great. But there you go. You start with 2, you go up to 12, and there's a pattern to the grid there. Okay, it's just all the possible sums. Now let's reduce that, and my answer is 1/6. Probability is 1/6. Okay, now what's the probability of getting a sum of 4 or 5? Now, or in probability means to add. And means to multiply, or means to add. So let's add the ways we can get a 4 to the ways we can get a 5. There's 36 possible sums. There are 3 ways to get a 4. I could roll a 1 and a 3. I could roll a 2 and a 2, or I could roll a 3 and a 1. Think of these as 2 distinct different dies. One's like, let's say, red, and one is green, okay? So there are 3 ways to get a 4, and then there's 1, 2, 3, 4 ways to get a 5. So I've got 4 plus 3 is 7. So remember, I add the ways I can get a sum of 4 to the number of ways I can get a 5, and I get 7 out of 36. Okay, now, what if and this is new. This is a little bit trickier, okay? And I'm going to get my calculator ready because we're going to be doing some combination stuff here. Okay, now, let's say that I have, and this is going to get in the way, I have 12 tulip bulbs. Okay, I have 12 tulip bulbs. They're in a bag, and I'm going to plant them. Now, of those 12 bulbs, 9 are yellow and 3 are red. Now, you've never done this before. I'm going to reach in and grab 2 at a time, okay? When we did probability in past years, you might grab one and keep it out and grab another, or you might grab one, put it back in and grab another. We've done that before, but this is different. This is reaching down into a bag, grabbing a group of 2 bulbs, okay, and pulling them out. Well, what do we know about a group where the order doesn't matter, okay? I can just grab a bulb, okay, grab a pair of bulbs, and the order of the bulbs in my hand doesn't matter, just like having 2 cards from a deck, and it doesn't matter if I have a queen and a king or a king and a queen. I'm just grabbing a general group of 2 bulbs. So we're going to use combination here to see how many different ways I can form a group of 2 bulbs. Now, the first thing I want to do is what's the probability that both will be red? So what I'm going to do is figure out, first of all, the denominator, how many groups of 2 bulbs can I get in all? Well, I have a total of 12, and so how many groups of 2 can I get out of 12 bulbs? Now, in the numerator, I'm just focusing on how many groups of 2 reds I can do. Well, there's 3 red bulbs, and so I want to get a group of 2. And this is my answer. My answer is my combination of 3 reds. How many ways can I get a group of 2 reds out of 3? So I'm going to go ahead and do 3, and then I'm going to do probability of a combination of 2. And there are 3 ways that I can get a group of 2 bulbs, okay? Now, let's go to 12. Out of 12 bulbs, how many ways can I have a general group of 2? 66. And so this reduces to 1 over 22. Have I run out of room? Can you see it? 1 out of 22. That's my probability of reaching in and getting a group of 2, okay? Now, it didn't tell me that I'm going to reach in, take it out, and then reach in the second time. I'm reaching in and grabbing a group of 2. When we're grabbing a group, we're going to use combination. Now, let's try this next one. What if I have, well, I know my denominator is going to be 66. That's not going to change because I'm grabbing how many total groups of 2 can I get? There's 66 groups of 2 I could get. But I want to get 1 yellow and 1 red. Okay, let's start with how many ways can I get 1 yellow? Well, there are 9 yellow bulbs, and I want to choose 1, a group of 1. And then an and means to multiply, and means to multiply, or means to add, and means to multiply. And out of 3 red bulbs, I'm going to choose 1. Well, I can tell you without having to do anything there that how many ways out of 9 combination choose 1, there's going to be 9, and 3 choose 1 is going to be 3. And so I'm going to have 27 over 66. Well, let's divide both of those by 3, and I get 9 11ths. So I have a 9 out of 11 chance of getting 1 yellow and 1 red bulb when I reach in and grab the group. Okay. All right. That's not right. What is my problem? 66 divided by 3 is not 11. Crazy teacher. It is 22. I'm so sorry. All right. Did I reduce that one correctly? I did. Okay. We're good. Are we all good? We're good. Okay. Now, last thing I want to say is you're going to have some problems about flipping a coin. The best way to do a coin flip, if you have to flip 2 coins or 3 coins, make yourself a diagram, a tree diagram. So I'm going to erase this diagram real quickly right here. And I'm going to go ahead and say, what if I was going to flip 3 coins? Okay. So I can choose heads or tails, heads or tails, heads or tails. Okay, so I flipped a coin the first time, and then my second one, if I flip heads the first time, here's my 2 choices, heads or tails here for the second. And let's go ahead and branch off again and do a third flip here. Okay, so I've got this fun little tree diagram here, but it really is helpful for the homework for today. Now, let's just do, what's the it looks like a T. do, what's the probability of getting, let's do at least one tail. Okay, at least one tail, because this is where it gets tricky. All right, so at least one tail. Well, how many total outcomes am I going to have? See, here's heads, 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 tails. So I can count this last column here to count my total number of outcomes. 1, 2, 3, 4, 5, 6, 7, 8 outcomes, and I want at least one tail. Okay, so at least one tail. Well, here's heads, heads, tails. That's at least one. Here's heads, tails, heads. That's at least one. Here's heads, tails, tails. There's 2 tails, but it's at least one. Tails, heads, heads. Got a tails. These all have at least one tail. So what do I have here? 7 out of 8. There's 7 out of 8 ways for me to get at least one tail. You could also use this diagram. What's the probability of getting exactly 2 tails? Exactly 2 tails? Well, I see 2 tails right here, 1, and I see 2 tails here and here. So that looks like 3/8 to me. 1, 2, 3/8. So anyway, but you can use your tree diagram to help you with the head tails homework tonight. Okay. Well, that's it. And I hope you have a blessed Tuesday. And we have one more section in this chapter, and then I'm going to tag on a little bit of matrices before we take our last test, because this is kind of the short part of this chapter, and I think I'd rather go ahead and add some matrices on there before we take our test. So we'll take our test next week. I will still drop the lowest one out of the 3 tests we've taken, which is really nice of me since it's been totally open book, but I haven't been there to help you as much as I could. So if we were together. So anyway, so we'll have one more test next week, and you can, we'll drop your lowest one. Okay. All righty, so that's probability. Got a little bit of combination in here. Make sure you reduce your fractions correctly after you do all that work. Okay. All right. Well, have a blessed Tuesday. I may have already said that, and I will be back with you. I'll be with you during Zoom today if you need me, or I'll be back tomorrow morning. Have a great day.